Hello everybody, welcome back to Beginning Algebra. Today we are in section 2.2 and we're going to be looking at the multiplication property of equality. So last time we looked at the addition property of equality and we learned how to solve equations by either adding the same thing to both sides or subtracting the same thing from both sides. Today is the multiplication property of equality, so we will either be multiplying both sides by the same number or dividing both sides by the same number. So we'll do examples with both of those things that I just mentioned, and then we will also look at some equations where you have to simplify before you can actually solve by multiplying or dividing by the same number. Here we go. So like I was saying on the last slide, just as we can add the same value to both sides of an equation, we can also multiply or divide both sides of an equation by the same value. Our goal is still to solve the equation by isolating the variable. Anytime the instructions say solve, your goal is to isolate the variable. And we'll do this by taking advantage of the fact that any number divided by itself equals 1. So if we have a number as a factor of the top and also a factor of the denominator, then that number divided by itself will make a 1. In other words, sometimes we say that those two numbers cancel each other out. So think about the equation 3 times x equals 15. Now I know that when you look at this equation, you instantly know that x has to be 5 to make the equation true, but remember, we need for the solving process to force the answer to show up. So to isolate the variable, we need to eliminate the coefficient of 3. And we can do this if we multiply both sides by the reciprocal of 3, which is 1/3. So we would have this equation, 3 times x equals 15. We would multiply both sides by 1/3. And then we would say 1 times 3x divided by 3 would be 3x over 3 like this. And 15 times 1 divided by 3 would be 15 divided by 3 like this. Now here 3 divided by 3 is 1. So we just say that these 3's divide out, or sometimes we say cancel out. Over here 15 divided by 3 is 5. So the solution here comes out x equals 5. Now you might have noticed on the last slide that multiplying both sides by a fraction was just a little bit awkward. So we can keep things a little simpler from that. From now on, if the coefficient is an integer, by which we mean a positive or a negative whole number, we'll show the solving process with division instead of showing that we're multiplying by the reciprocal. So take an equation like the one we had before, 3x equals 15. Instead of multiplying both sides by 1/3, what we'll do is just show that we're dividing both sides by 3. Remember, dividing is the same as multiplying by the reciprocal. So we'll show division by 3 on the left and division by 3 on the right. Now if you're in one of our online courses and you have to show your work in the show work window when you take your quiz, then this is what you need your work to look like. And here's just a tip for you. I think a lot of times it's easier to type the slash first, and that way you get a fraction template with a top and a bottom. So if you need to type something like this, you could actually hit the slash first, and then use the up and down arrows to move your cursor from the top to the bottom of the fraction. Type the 3x into the top, type the 3 into the denominator, and then right arrow so you're out of the fraction. And then you can type equals, and you can either type 15/3, or you could again type the slash first, and it will give you a blank fraction template to type in. So that's just a tip for you, because you do want your work to look like this. And from here, just like we did on the last slide, we can let the 3's divide out, and so we'll get x equals 5. And this is how your work should look when you have to show your work in a show work window on a quiz or a test. Okay, so let's look at example 1 together, and let's also check our solutions after we find them, just like we did in the last section. And remember that although the answer here is important, the way you show your work is even more important. So I would want you to pay very close attention to making sure that your work looks like the work I'm showing here. So here we have 5 times x equals 60. This 5 is a coefficient. So in order to eliminate this coefficient, we would need to divide this side by 5. If we divide the left side by 5, we must also divide the right side by 5. So I'll put divided by 5 here and divided by 5 here. So remember this old division symbol that we have used in the past? When we're solving equations, I want you to treat that like an absolute no-no. You need to always show division using fraction form the way we have it here. Okay, now a 5 in the top and a 5 in the bottom will divide out and make a 1, or we could say that the 5's cancel. And we'll have x equals 60 divided by 5, which reduces to 12. Okay, now let's check our solution. So we'll take our original equation, which was 5x equals 60, and we'll substitute the 12 in place of the x. So we'll have 5 times 12 equals 60, and there's that question mark again to remind us that we're trying to verify this here. So 5 times 12 is 60, and now we have a true equation, and we can say for sure that 12 is the right solution. And now remember, when you go to MyLabs Plus to put your answer in, this is what they will already have on the screen. The solution set is, and you'll need to just fill in the blank. And remember, you don't want to type x equals 12. This is set notation, so you just want to put 12 inside the curly braces. Now here is a practice one for you to try on your own. So pause the video and give it a try by yourself. And now let's go through it together. This says 15 times x equals 75. So we need to eliminate the times 15. In other words, we need to divide both sides by 15. So we'll show divided by 15 on the left and divided by 15 on the right. And now 15 divided by 15 is 1. So the 15s cancel each other out. And our solution is x equals 75 divided by 15, which is 5. Now, since this is beginning algebra and you don't have access to a calculator, you might not automatically know that 75 divided by 15 is 5. And I know that you don't want to go through the long division process because nobody enjoys that process. So I thought we'd just look at how to simplify this and see that it goes to 5. So let's start with 75 divided by 15 in fraction form. And just remember how you simplify fractions. 75, you know, is 3 times 25 because 75 cents is 3/4. 15 is 3 times 5. So now notice that 3 and 3 will cancel out, and that leaves us 25 divided by 5, which you do know by heart. 25 divided by 5 is 5 exactly. Okay, now that we've established that 5 is our solution, let's check our solution. So we want to replace the x in the equation with our solution, which is 5. So we'll have 15 times 5 equals 75, and we're trying to verify that this is true. All right, 15 times 5 we know for sure is 75. So now our equation says that 75 equals 75. That is known to be true. And so we just verified that 5 is our solution. In MyLabs Plus, of course, when you see the curly braces, just put the solution 5 inside the braces. Here is example 2. We have negative 25 times p equals 30. And again, as always, we're trying to isolate the variable, so we need to eliminate this coefficient. Now, this is a place where a lot of students get confused because they know they ought to divide, but for some reason they want to divide by the opposite sign. That's not going to work because remember, we want the coefficient of p to be positive 1. If we have negative 25 in the top, and we divide by positive 25, then yes, the 25s will divide out and make 1, but negative divided by positive will be negative 1. So we'll actually end up with negative p. We don't want that. We want to end up with a coefficient that is positive 1. So whatever the coefficient is, you'll want to divide both sides by that coefficient. Here the coefficient is negative 25, so I'm going to divide the left side by negative 25, and also the right side divided by negative 25. Now notice that negative divided by negative would be positive. So negative 25 divided by negative 25 makes this coefficient positive 1, which is exactly what we want. So the negative 25's cancel, and then we'll have P equals, on the right side we have 30 divided by negative 25. Now this will not make a whole number. And also notice that we have the negative sign in the denominator. And we've talked before about how we should not leave the negative in the denominator. So our choices are to either move the negative to the front of the fraction or move the negative to the top of the fraction. Either way, the entire right side has a negative value. So I'm going to go ahead and put a negative here. And now, since I can't reduce this to a whole number, I'll just reduce the fraction. 30 and 25 can both be divided by 5. 30 divided by 5 is 6, and 25 divided by 5 is 5. So there is the final form of our answer. So P equals negative 6/5. Now let's check our solution. So we want to plug negative 6/5 in place of the variable. So we'll have negative 25 times P, which is now negative 6/5, equals 30. And we just want to verify that this is true. Okay, notice that negative times negative is going to make the left side positive, but remember, we don't want to have to multiply 25 times 6 because that's going to make a large number. Let's take advantage of the fact that 25 divided by 5 makes a whole number. So 25 divided by 5 makes 5, and then we would have negative 5 times negative 6 equals 30, and we know that's true. Negative 5 times negative 6 is 30. So we have verified that our solution is true. And now to put it in set notation, we'll just say the solution set is negative 6/5. Now here is a practice one for you to try on your own. So pause the video and give it a try. Now let's go through it together. So we have negative 6z equals 14. So we need to eliminate this coefficient of negative 6. So let's divide both sides by negative 6. So I'll put divided by negative 6 on the left and divided by negative 6 on the right. Now on the left side, negative 6 divided by negative 6 is positive 1. That's what we need. So let the negative 6's cancel out. And you'll have z equals 14 divided by negative 6. Now remember, positive divided by negative makes a negative answer. So you need to either move the negative to the front of the fraction or you could attach the negative to the top. Either way is fine. And we know that 14 divided by 6 is not a whole number, but we know that this fraction can be reduced. So I'm going to have a negative solution. Then 14 and 6 can both be divided by 2. 14 divided by 2 is 7, and 6 divided by 2 is 3. So our solution is that z equals negative 7/3. Now let's check our solution. So we'll put negative 7/3 in place of the variable, and that will give us negative 6 times negative 7/3 equals 14. And remember, we're not saying this is true, we're trying to verify that this is true. Okay, now we don't want to have to do negative 6 times negative 7 because that makes a larger number that we would then have to divide by 3. What you want to do is take advantage of the fact that 6 divided by 3 is a whole number. So let's just put a circle around that. Now 6 divided by 3 is 2. So we'll have negative 2 times negative 7, and that's supposed to equal 14. So let's make sure. Negative times negative is positive. 2 times 7 is 14. So yes, 14 equals 14. That's a true statement. So our solution is verified. And in set notation, we could say that the solution set is negative 7/3. Now the same way we eliminated integer coefficients by dividing both sides by the same number, we can eliminate values in the denominator if we multiply both sides by the same number. So let's look at example 3. Here we have x divided by 4 equals 3. So the opposite of divided by is multiplied by. So remember, we could cancel a factor from the top if we divided by that same number. We can cancel a factor from the bottom if we multiply by that same number. So I'm going to show multiplication by 4 on both sides here. 4 divided by 4 will still make 1, and we'll still be able to cancel out those 4's. And now this gives us x equals 3 times 4, which is 12. Okay, now let's check our solution. So we'll put the 12 in place of the x. We'll have 12 divided by 4 equals 3, because that was our original equation. And we know this is true. We know 12 divided by 4 is 3. So we get a true equation, and in set notation, our solution would be 12. Okay, now you practice this similar equation. So pause the video and try it on your own. Now let's go through it together. So we have x divided by 5 equals negative 10. We want to cancel out this divided by 5. So we need to put a times 5 in the numerator. So multiply the left side by 5, multiply the right side by 5. Now 5 divided by 5 is 1, and we have x equals negative 10 times 5, which is negative 50. Let's check that solution. So we'll put negative 50 divided by 5 equals negative 10, and we'll just verify that negative 50 divided by 5 would be negative 10, and so we know our solution is correct. And in set notation, we can say that the solution set is negative 50. Now remember, I don't really expect you to write down the checking part every single time on every single equation. The only time you have to type the checking part into a show work window on a quiz or a test is if the instructions say that you have to check your answer. So in that case, part of what we're grading is that you know how to check. But normally it's enough to just take your solution and mentally go back and say, yeah, negative 50 divided by 5 is negative 10, so I'm in good shape. I just want you to take a few seconds and think about what your solution is and whether it makes sense. That's really all I'm asking. Okay, let's look at how to eliminate a fractional coefficient. A lot of times students want to show eliminating a fractional coefficient like this by showing division this way. They want to say divided by 3/4 on the left and divided by 3/4 on the right. And while this is not technically wrong, it is complicated. How many people can mentally evaluate 6 divided by 3/4? Not very many. So this is not how you're going to work out the problem. Instead, I want you to think about how could you eliminate a 3 from the top? Well, you would need to multiply a 3 into the denominator. And how do we eliminate a factor from the denominator? Well, we multiply that factor into the top. So we're going to do the same thing here. To eliminate a fractional coefficient, instead of showing it as division, it's easier to show multiplication by the reciprocal. Remember, division is multiplying by the reciprocal. So here, if I'm going to eliminate this coefficient of 3/4, I need to multiply the left side by 4/3. So see how this is going to work? The 4's are going to cancel and the 3's are going to cancel. Okay, so I need to also do the same thing to the right side. I multiplied the left side by 4/3. I need to also multiply the right side by 4/3. So I've done the same thing to both sides. And now we need to evaluate what we have on the right side. So we have 6 times 4/3. And remember, I'm trying to get you to develop this habit of simplifying first. So notice that 6 divided by 3 would give us a whole number. So we're going to do that first. 6 divided by 3 would be 2. That 2 times this 4 would be 8. So we have come up with a solution of 8. Let's check that solution by putting this in place of the variable. So 3/4 times 8 will become 3/4 times 8, and that's supposed to equal 6. So let's see if that is the case. So again, we have this situation where we have a number in the top divided by this number in the bottom, and it will make a whole number. So 8 divided by 4 is 2. This 3 times this 2 is supposed to be equal to 6, and we know 3 times 2 is 6, so that checks. And we can say that our solution set is 8. Okay, now I would like for you to try this one on your own So if you would like to pause the video and try it, I think that's great. I'm going to go through it with you now. So here we have negative 5/6 times m equals negative 15. So we would like to cancel out or eliminate this negative 5/6. So remember, the way to eliminate a fractional coefficient is to multiply by its reciprocal. And I also want you to remember that a pair of reciprocals always have the same sign. So the reciprocal of negative 5/6 is going to be negative 6/5. Okay, now since we have multiplied the left side by negative 6/5, we must also multiply the right side by negative 6/5. Now over here on the left, negative times negative is going to make positive. Then the 5's will cancel and the 6's will cancel. So our coefficient here ends up being positive 1. And we have 1m on the left. And on the right, I want you to notice that 15 divided by 5 will make 3. So now we have negative 3 times negative 6. Negative 3 times negative 6 is positive 18. So we have come up here with a solution of 18. Let's check that solution. So we'll say negative 5/6 times 18 is equal to negative 15. And remember, nobody expects you to have to work out 5 times 18. Instead, a better strategy, again, is to do the simplifying first. So we notice that 18 divided by 6 is going to make positive 3. So now this is giving us negative 5 times positive 3. And we know that negative 5 times positive 3 is equal to negative 15. So our equation is true, and we have verified that this answer is correct. And we can say that the solution set for this equation is positive 18. Now, sometimes it happens in the solving process that you will end up with negative 1 as your coefficient. And you can't leave your solution that way, because when you solve for x, you need to be solving for positive x, not negative x. So if you have a coefficient of negative 1, you must divide both sides by negative 1 so that you end up with a positive variable. So here we have an equation that says negative k equals negative 15. Treat that negative as a coefficient of negative 1, and let's divide both sides by negative 1. So here, negative 1k divided by negative 1 is going to make positive k, and on the right side, negative 15 divided by negative 1 is positive 15. Okay, let's check. Negative k would be negative 15, and that's supposed to equal negative 15. Of course, that's true, and we have verified that the correct solution is 15. So we can state that the solution to this original equation is positive 15. Now let's look at some equations where we have to do a little simplifying before we can solve. Here on example 6, we have 5m plus 6m equals 33. So notice that I have two m terms over here. These should be combined first. So we know 5m plus 6m is 11m. So now we have 11m equals 33, and we can see that to isolate the m, we should divide both sides by 11. So I'll just say divided by 11 on the left and divided by 11 on the right. Of course, the 11's divide out, and we are left with m equals 33 divided by 11, which is 3. And now let's check that in our original equation. So we'll have 5 times 3 plus 6 times 3 equals 33. And let's just verify this. 5 times 3 is 15. 6 times 3 is 18. And so now we need to make sure that 15 plus 18 equals 33. We know that's true. So we know that this solution is correct. And we would say the solution set here is 3. So here's one for you to try. This is very similar to the last example we did. Here we have 7r minus 5r equals negative 12. Of course, the two terms on the left need to be combined. 7r minus 5r is 2r. And now we need to eliminate this coefficient. So we will divide both sides by 2. And then we can let 2 divided by 2 simplify to 1. And we'll have r equals negative 12 divided by 2, which is just negative 6. And let's check our work. Here we would have 7 times negative 6 minus 5 times negative 6 equals negative 12. And so let's evaluate these two products over here. 7 times negative 6 would be negative 42. And then treat this minus as a negative for purposes of our sign rules. Negative 5 times negative 6 would be positive 30, so we'll write plus 30. And we just need to make sure that the left side adds up to negative 12. So of course negative 42 plus 30 would add up to negative 12. So that shows that our solution is correct, and we can say that the solution set here is negative 6. And now we have an example where we must apply the distributive property first to eliminate the parentheses before we can start the solving process. So here we have 4 times x minus 1 minus 2 times x minus 2 equals negative 12. Let's distribute the 4 here. So 4 times x would be 4x. Minus 4 times 1 would be minus 4. And then distributing the negative 2 here. Be careful that you distribute the negative 2 and not just 2. Negative 2 times x would be minus 2x. Negative 2 times negative 2 would be positive 4. This is a source of a million sign errors for a million different students. You've got to be careful when you distribute a negative. And then, of course, the right side is negative 12. Now let's combine terms on the left side. Here we have 4x and minus 2x. Together they make positive 2x. And then we have negative 4 and positive 4. Together they add up to 0. So there's nothing else on the left side. And the right side is negative 12. And now you can see that to isolate the x, we need to divide both sides by 2. And so 2 divided by 2 is 1. And that will give us x equals negative 12 divided by 2, which is negative 6. And now let's check our work by plugging negative 6 into the original equation. So we'll have 4 times negative 6 minus 1 minus 2 times negative 6 minus 2. And we need to make sure that that adds up to negative 12. Okay, now you don't have to distribute, although you can if you want to. You now have numbers inside the parentheses, and you can work these operations. So I'm going to go ahead and do both of these subtractions. Negative 6 minus 1 is negative 7. So 4 times this parentheses will be 4 times negative 7. And then we have negative 6 minus 2, which adds up to negative 8. So we'll have minus 2 times negative 8. And I need to make sure again that that adds up to negative 12. Okay, 4 times negative 7 is negative 28. Negative 2 times negative 8 is positive 16. And now we know that negative 28 plus 16 would add up to negative 12. So we verified that the equation is true, and we can say that our solution set is negative 6. Now please pause the video and try to work this one out by yourself before you watch me do it. Okay, now I'm going to go through it with you. So again, we have parentheses. We must eliminate parentheses before we start the solving process. So 5 times x would be 5x. 5 times 2 would be 10. And now distributing the minus sign here, we'll get minus 3x and minus 10, and that's equal to 14. Okay, combining like terms on the left, 5x minus 3x will give us 2x. And positive 10 minus 10 will give us 0, so there will be no other terms on the left, and that equals 14. And now we need to eliminate this coefficient of 2, so we'll divide both sides by 2. The 2's on the left will cancel, and we'll get x equals 7. Okay, now let's check our work. So we'll have 5 times 7 plus 2 minus 3 times 7 plus 10, and that's supposed to equal 14. So let's work the operations inside the parentheses first. So we know that 7 plus 2 is 9. And here we know that 3 times 7 is 21. So now we need to work the addition inside this second set of parentheses. 21 plus 10 is going to be 31. So we'll have 5 times 9, which is 45, minus 31. And that's supposed to be equal to 14. If you work out the left side, you do get 14, so we verified our solution, and now we can say that the solution set is 7. And now I want you guys to think about how far you've come from the beginning of the last section. When we first started this section, we officially knew nothing about solving, and now look at us solving equations that are actually pretty complicated, and we're going to go even a little further in the next section. But honestly, right now, you have almost all the skills you need to solve any linear equation out there. So, keep practicing this. This is a very valuable skill. It's one that you have to use over and over again. So I cannot emphasize enough the importance of practice here. I want you to really spend some time on this, and you'll see that when you spend a little time, your skills develop very quickly.